so 9, 4, direct variation. So here's your definition. You might look at it and say, I don't get it. I'll explain it to you, but you need to write down everything that's behind it. So direct variation, always linear, so always a straight line. Always passes through the origin. You've heard these two things before already this year. When did you hear these two things? What were we talking about when we said, no? Proportions. Remember, proportions had it all through the origin. They all had a straight line. Remember that? What were other ways you could tell if things are in proportion again? If they equal the same thing, so if they were fraction, they reduce to the same thing. If you divide them and they divide it to the same thing. So keep that in mind today, because it's a lot the same as direct variation. And if you think about proportion, remember, everything was constantly the same. It was either all going up by 4 or timesing by 6 or whatever. Direct variation is about the same thing. All right, so what does some of this mean? Well, here's what it means for us. What we're doing is we're going to write a rule. Okay, that's the simple thing. We're going to write a rule for something. Now, some of you are like, rule? I don't get it. I'll show you. I will show you. So we're going to write a rule. And what I'm going to do is I'm going to show you my table. And we kind of did this probably already with proportions. And you've seen something like this already this chapter, only you saw it like this. Remember, we had an x and a y, and we put a function in here. Remember that? And then we had some numbers on the sides. Well, here's the thing today. They're going to give us the x and y, but guess what we have to find? We have to find the function. That's what we're going to do. We're going to find the relationships between what's here and here and figuring out what's going on. So instead of looking down like this today, kind of like what we've been doing, we're going to look the other way. We're going to look across, right? So we're going to look from here to here, here to here, here to here to here to here. And so this is a really simple example. Okay. So if I look at this, what's happening between 2 and 4 and 3 and 6 and 4 and 8 and 5 and 10? What's going on? Okay, I'm doubling it. Or what am I really doing to the 2? I'm multiplying by 2, right? Okay, so let's start writing our rule for this. We know we take everything that's in my x column and what do we do with it? Okay, yeah, everything in our x column, we're multiplying by 2. So 2 times whatever's in my x column, and what's that going to equal? What's in my y column? Does that make sense so far? So what we just did is we found out what was going on, and we say, okay, we know in everything in our x column, we're taking times 2. Here's my x column. And what does that give me? It gives me what's my y column. Okay. That's what we have to do. Yep, you're using what you're given. You have to figure out if it's direct variation or not. Okay. So, and another really smart thing to do is say, okay, well, I don't really know what's going on here. Let's say it's confusing. You're like, I don't get it. Guess what you can do? What's 4 divided by 2 and 6 divided by 3 and 8 divided by 4? What's it going to be? And guess what? Okay, so that's another simple way to say, well, I don't know I don't know what's going on. Well, go the backwards then. Say y divided by x is what? What's 4 divided by 2? 2. 6 divided by 3 is 2. So I know that every time I have something in x column, I'm multiplying by 2. Okay, and I'll do another example of that in a second. All right, so direct variation. There's actually a formula for it, and you already know it. You just didn't know it. You know it, but you didn't. Here's my formulas. I have 2 of them, and each of them can be used different ways. This one we're going to use a lot. You probably saw it, kind of just what we did before. And then this one over here is kind of like if you don't know that constant, like what I just said to Maddie, like if you don't know what you're going up by, you can take your y divided by your x, and it's going to give you your constant. And some of you are like, K, where's K coming from? Another variable? What is that? It's just the constant. It's what it's constantly going up by. Like the last one, what were we constantly going up by? 2. So that's my constant. So don't let another variable freak you out. It's just a constant, a variation. That's what we just put. We just make it a letter. It's a fixed number. It's consistent. It's always going to be there. And that's too why we had to talk about a constant of what did we call it yesterday? Constant rate of change, is that what we called it? The constant rate of change, that's what this is. We had to find that constant, remember? Like the first one was 25 cents for every one. The second one was, I don't remember, 96 feet below for every 1 centimeter. I don't remember what it was, but that's what we had to do that so we could start figuring out what this is. Okay, so does everybody have this written down? Okay, I'm going to go back a second. So if I go back down here, what's my constant in this equation? 2. It's never going to change. That's the only thing that's always going to be there. What are things that are going to change in my equation? X and Y. Because remember, what I put in for X, does that depend what I'm going to get out for Y? Yes. Now, some of you are maybe like, well, what about this one? That's the one I was just talking about. So if I didn't know what my constant was, I could take something from my Y column and something from my X column. And guess what that's going to give me? 2, which 2 is always my constant. So that's another equation you can use to figure out that constant. All right, so let's do another one. Let's do this one. So we're going to, for number 1, we're going to tell if this is a direct variation or not. Okay. So they give me a table, and notice my X is on the top, my Y is on the bottom this time. I just flipped the table. First thing I need to do, is it consistent? Is my table consistent? If I look here, it's going to always be going up by 1. This is always going to be going up by 3. Okay, that's a good start. That's a good start. Now, maybe another thing I could look at, I could say, okay, well, I don't know if this is in proportion or not, which there's going to be one like this on your homework today. You're going to say to yourself, I don't know if this is in proportion. Then go back to this and say, okay, I'm going to divide all these, and they all have to come out to the same constant. It's like proportion. Remember, we had to find if we divided them, they had to be the same. Remember? Well, the same thing is here. So if I say, okay, well, 3 divided by 1, what's that equal? 3. 6 divided by 2, that equals 3. 9 divided by 3, that equals 3. Is this going to be is it direct variation? Yeah, because what's happening? They're all going up by 3, right? Okay. Remember this for your homework today, because there's a few tables, and you're going to say, oh, I don't know if this is in direct variation or not. It looks like it. If I go like this, you know what, they're all the same, but I better just make sure by using my equation. Okay, it's going to happen. So let's write a function out, a function for this, or a rule for this. Maddie? 3x equals y. How do you know that? So every time, right? 3 times 1 is 3, 2 times 3 is 6. So 3x equals y. So everybody understand how I got that now? Yes? It is simple if you think about it. Why was I so worried about teaching this? Sure. Sure. So another thing too is I can look to say, okay, I know k is my constant, kx equals y. That's my other equation, right? If my constant was 3 through here, what am I going to put in here then? I'm going to put in 3 for my k. And that's the answer. Yes, it's just the constant. That's what we've been doing. Yes, good. So then let's take it a step further. And let's say if I say, okay, what if it weighs 10 pounds? What's my price? What can I do with that 10 then? Put it in for x. And guess what it's going to weigh? 30. So your homework is going to have you do that too. It's going to give you something. You have to write the equation, and then they're going to ask you a question, kind of like I did. Now, if I make it, if it's 10 pounds, what's the price going to be? Okay. Any questions so far? We're doing okay. Yeah, really? No, this is really pretty much it. I want to do a story problem with you though, if I can get to it, right here. And then we're actually going to do some in the book together, so we're kind of on the same page. Okay? So here's my story problem for you. It says, write a direct variation equation from the story. A turtle travels on the ground at a speed of 18 feet per minute. Wait, per minute? Oh my gosh. That's pretty fast. 18 feet per minute? How many feet can it travel in X minutes? So, what's the constant in here? What's never ever going to change with this guy? 18. He's constantly traveling 18 feet per minute. I actually think that's fast. He must be a turtle because 18 feet is pretty fast for a minute. Okay, so 18 feet. Then what? X equals y. Because what does the X mean? Minutes. That's going to be my minutes, right? And this is going to be my feet in the end of how far he goes. You guys understand that? Yes? I would make a table. I'll say, okay, for every 1 minute, they're going to go 18 feet. For every 2 minutes, it's going to be 36 feet. And this would have been 18x equals y would have been my, looks like a 78, it's an 18. Yeah, a lot of that's all you have to do today. But we're going to actually get a book down. We're going to go through some of the practice problems in our book just to make sure we're all on the same page. So I think it's on page 408. Let's try 408. And I'm probably not going to record the rest of it, but